Good day everyone. Today we will discuss the relationship of rational exponents and radicals. I hope you can still remember our previous lesson about the laws of exponents because that is significant for our discussion today and to the next days. Okay, so let us discuss first our first definition of b raised to 1 over n. For a real number b and any positive integer n, take note that your n here is greater than or equal to 2. So we can have the values of n, which is 2, 3, 4, 5, 6, up to the positive infinity. And b raised to 1 over n is equivalent to the nth root of b, except when a is less than 0 and n is even. Next, definition of b raised to m over n. The difference between the second and the first one is the numerator. For our first definition, the numerator here is 1. And for our second definition, the numerator here is any real number. Okay, so for any non-zero real number b and m all over n, be a rational number with positive integer n. Again, the values of n here is greater than or equal to 2. So we have here b raised to m over n is also equivalent to the nth root of b raised to m. Or you can have the nth root of b raised to m, except when b is less than 0 and n is even. Take note that the values of b there is what we call the base. Okay? So now let us answer the following examples. And we will use the two definitions, which are b raised to 1 over n and of course b raised to m over n. Number 1, b raised to 3 over n. Always remember that the denominator is our index. So it is equivalent to the nth root of b cubed, or we have nth root of b cubed. This is our example the answer for our example number 1. I repeat, the denominator will be our index. Okay, number 2, the quantity of x cubed, y squared raised to 1 over 4. The denominator will be our index. So we will just copy this one, our base. So we have 4th root of x cubed y squared. That is now our answer. Number 3, the quantity of a raised to 5, b cubed raised to 1/2. So here we have the square root of a raised to 5 b cubed. Isn't it that 2 here for square root is no longer written, so it can also be just the square root of a raised to 5 b cubed. Number 4, m squared n raised to 1/4. So we have, you need to apply the laws of exponent here for number 4. M raised to 2 times 1 all over 4. So that will give us m raised to 1 over 4, because 2 times 1 is 2 divided by 4, that is 1/4. Or you can just write it like m raised to 2 over 4, and then n times 1/4, that is 1 over 4. We have here now the exponent with same base, that will be our index. So the answer is 4th root of m squared, and then n raised to 1, or just n. So this is our answer for number 4. Number 5. The quantity of a raised to 6b cubed raised to 1/2. Again, the denominator is the index, and we have square root. And then a raised to 6, and then b raised to 3, or b cubed. That is our answer for number 5. Next, number 6. 7 raised to 2/3. So we have cube root of 7 squared. So let us perform this one. 7 squared is 49. So we have cube root of 49. This is our answer for number 6. How about for number 8? We have square root. So the square root of 8. That is the answer. For number 8, we have 3y raised to 2/5. So 5 here is our index. So we have 5th root of 3. Apply the laws of exponent. 3 squared, and then y squared. So we have 5th root of 3 squared, that is 9. Copy y squared. This is our answer for number 8. Okay? So for the next examples, you can solve it on your own. You can pause the video and then just check your answer later on. Okay, let's answer number 9. 3x raised to 1/2, that is square root. So we have the square root of 3x. Number 10. 9ab raised to 3/4. 4 there as our denominator will be our index. And then distribute 3 to 9, a and b. Then later on we will simplify. So the answer will be 4th root of 9 cube, a cube, b cube. So we have the 4th root of 9 cube is 729 rather. And then a cube, b cube. 9 times 9 times 9, 729. Let's proceed with number 11. 27 over 64 raised to 1/3. So we have cube root of 27 over 64. That is our answer for number 11. Number 12. 2a squared b cubed raised to 1/3. So we have the cube root of 2a squared b cubed. Number 13. 3/4 raised to 1/2. That is square root. So we have square root of 3 over 4. Very easy, right? Next, number 14. 2a all over 9b raised to 1/3. So we have cube root of 2a over 9b. Last, 15. 27d cubed over 4c raised to 3 over 5. 5 will be our index, so we have the 5th root of, then distribute 3 for 27d, and then 4 ends. So we have here 27d cubed over 4c cubed. So if you will distribute, that will give you 27 cube b raised to 9 over 4 cube and then c cube. Then you can just simplify 27 cube and then 4 cube later on. So after writing each of the following as radicals, let us now proceed in writing the following radicals as powers with rational exponent. Okay, the first one we have here, the cube root of a raised to 2. This is equivalent to, we all know that the index here serves as the denominator. So we have a raised to 2 over 3. This is our answer for number 1. Next, cube root of a times b raised to 4. Again, the index is our denominator. So we have the quantity of ab raised to 4 over 3. Number 3, the square root of x raised to 101. We know that square root has an index of 2. So we have here x raised to 101 over 2. Number 4, ninth root of xy raised to 21. The answer is very good. Xy raised to 21 over 9. Number 5, fifth root of a squared b cubed c raised to 4 is very good. We have a squared b cubed c raised to 4 raised to 1 over 5. Next, number 6, square root of 5. The answer is very good. 5 raised to 1 over 2 or 1/2. How about number 7? The answer is very good. Y raised to 2/3. Number 8, fifth root of 120 ab squared. Very good. 120 ab squared raised to 1 over 5. Next, number 9. We have nth root of 9x. Number 9, we have the nth root of 9 y squared x. And that is equivalent to 9 x y squared raised to 1 over n. Okay? Number 10. Fourth root of 14x. The answer is 14x raised to 1 over 4. Number 11. 8th root of x. We have x raised to 1 over 8. Number 12, 9a cubed square root of 2. Number 9, the answer is, okay, so we have here 2 raised to 1 over 2 times 9a cubed. Number 13, what is the answer? Very good. 3/4 raised to 1/3. Number 14. What is the answer? Very good. We have 6 all over a squared raised to 1/5. How about for the last number 15, the cube root of negative 64m raised to 6. The answer is negative 64 m raised to 6 raised to 1/3. Okay, I hope you learned something about our discussion for rational exponents and radicals using the definition of b raised to 1 over n and then b raised to m over n. So b raised to 1 over n is also equivalent to the nth root of b, except when a is less than 0 and n is even. For the second definition, b raised to m over n is also equivalent to nth root of b raised to m, or this one, except when b is less than 0 and n is even. So you already learned how to write each of the following as radicals, and of course, how to write each of the following radicals as power with rational exponents. Thank you and God bless.